Hello and welcome to Mathematical Coaching Center. Today in this video we'll be solving few problems related to angles in a circle, and this is the second part of the video, and if you have not seen the first part, the link is given in the description. But before we begin, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further ado, let's start. So we'll be using two theorems to solve our problems in this video. So let's see the first theorem that we will be using. So we'll be using the theorem which says the angles in the same segment of a circle are equal. So if we draw an angle in the same segment of a circle, then those angles will be equal. So let's understand this statement with the help of a diagram. So let there be a circle with center O, and if we draw a line segment in the circle choosing 2 points A and B, so this divides the circle into two parts. That is the major segment, that is this bigger part of the circle is the major segment, and the small part is the minor segment. And if we draw any angle in this major segment, okay, more than two angles in this major segment, then those angles will be equal. Also in the minor segment also, if we draw any angles in this minor segment, then those angles drawn on the minor segment will also be equal. So let's draw an angle in the major segment. Suppose choosing any point C, we are drawing an angle here, okay, that is standing at the base, that is AB. Okay, so this is the angle formed here. Okay, likewise, if we choose any other point D and draw an angle here, so there will be an angle here. So these two angles will be equal. These two angles will be equal. Okay, that is angle ACB will be equals to angle ADB. So this is what the statement of this theorem states. Okay, now let's see one more theorem that we will be using. The next theorem that we will be using is angle in the semicircle is a right angle. So let's understand this with the help of a diagram. So here, if there is a circle with center O, and if we make a semicircle, that is if we draw a diameter AB, okay, this divides the circle into two equal halves, that is semicircle. Now if we draw an angle in the semicircle choosing any point C, suppose if we choose a point C and if we draw an angle with the help of this point C, that is this angle here, okay, this angle formed here will be a right angle, that is this angle ACB. This angle, the measurement of this angle will be 90 degree or one right angle. Okay, ACB is one right angle, or angle ACB you can also say it to be 90 degree. So these are the two theorems that we will be using to solve our problem. So let's see the first problem. So in the first problem, it is given that in the figure given below, O is the center of the circle and angle PAB is equals to 45 degree, and we need to calculate the value of PQB. So let's start by writing what is given. Okay, so given that is angle PBA is equals to 45 degree. Let us see where this angle PBA lies in the diagram. Okay, so this is angle PBA, so this is angle PBA, and PQB is PQB, so this is the angle we need to find. Okay, so it is given that this angle is 45 degree, we need to find this angle. So let us see how we solve this problem. So let's see, here we can see that O is the center of the circle and AB is a straight line passing through the point O. That means AB will be a diameter. Now if AB is the diameter, then this circle is divided in two parts, that is the semicircle. Okay, now angle APB, that is this angle here, APB is the angle in the semicircle, so it will be 90 degree since this angle is a angle in the semicircle, so this angle will be 90 degree. Now we have the measurement of two angles, that is this is 90 and this is 45 degree. Okay, so what we will do is we'll find the measurement of this angle. So now in triangle APB, so this is triangle APB, so we have angle PAB, that is this angle here, PAB, plus angle APB, that is this angle here, and plus angle PBA, that is this angle here, and the sum of these three angles will be equal to 180 degree. And why is that so? Because it is the angles of a triangle will always be 180 degree. Okay, so this sum will be equal to 180 degree. Now we have the value of APB as 90 degree and PBA as 45 degrees. So after replacing the values, what we will get is angle PAB plus 90 plus 45 is equals to 180 degree. Now angle PAB plus 90 plus 45 is 135 is equals to 180 degree. Now taking 135 onto this side, we have angle PAB is 180 minus 35, that will give us 45 degree. So what is the measurement of angle PAB? It is 45 degrees. So the measurement of PAB is 45 degree. Now we need to find the measurement of this angle here. Okay, now we can clearly see that this angle PQB, that is this angle here, PQB, that is this angle here, will be equal to angle PAB, that is this angle here. Okay, and what is the reason behind these two angles being equal? It is the angles in the same segment. Now you can see that this angle PQB is standing on PB, okay, and this PAB is also standing at PB, okay, and it is drawn on the same segment, so this will be equal. So since angle in the same segment of circle are equal. Now what is the measurement of PAB? It is 45. Therefore what we can conclude is that angle PQB will also be 45 degree. So this is how we solve this problem. So let us see the next question. In the next question, it is given that in the figure given below, O is the center of the circle and angle DAC is 62 degree. Calculate the value of x. We need to find the value of x, that is this angle here. Okay, it is given in the diagram that this value is x and you need to find the value of this x. Now we'll, as always, we'll start by writing what is given. It is given that angle DAC is 62 degree. DAC, that is this angle here, is 62 degree. Now we'll take the help of triangle OAD, that is this triangle here. Okay, now what we will see in this triangle is that this triangle OAD is an isosceles triangle. Okay, OAD is an isosceles triangle. And why is that so? Because OA is equals to OD. OA is equal to OD. Now in this triangle, two sides are equal, means this is an isosceles triangle. And why is that so? Because these two sides are the radius. You can see that OA is the radius and OD is also radius of the same circle. That means these two lines segment will be equal. So OA is equals to OD. So triangle OAD is an isosceles triangle. Now if this is an isosceles triangle, then what happens is that angle opposite to equal sides will be equal. OD is equals to OA. That means angle opposite to OD will be equal to angle opposite to OA. Okay, because OA is equals to OD, angle opposite to equals sides will also be equal. That means angle ODA, that is this angle here, will be equal to angle DAC, that is this angle here. Okay, and we know the measurement of angle DAC, that is 62 degree. So what is the measurement of angle ODA? The measurement of angle ODA is 62 degree. Now we got the value of this angle, that is 62 degree. Now from the diagram, it's quite clear that what we will use is that angle X, that is this angle here, will be equal to angle BDA. Okay, this angle here. And why these two angles are equal? We see that this is drawn on the same segment. Suppose this the line here AB, so we can see that this angle is drawn in this segment. Okay, and this angle X is also drawn in this segment, and they are standing at the points A and B. Okay, so that means that these two angles will be equal. The reason is angles in the same segment of a circle are equal. Now what is the measurement of BDA? It is 62 degree. Therefore the value of X is 62 degree. So this is how we solve this question. So let us solve a final question. So in this question, it is given that in the figure given below, O is the center of the circle and angle CAB is 40 degree, and we need to calculate the value of X. Okay, we need to calculate this angle here. So to do that, we'll start as always by writing what is given. So given angle CAB is equals to 40 degree. So let's see where CAB is. So this is CAB. So here also we see that there's a straight line passing through the center, so we will be taking the help of this line as a diameter. So what we can say is that O is the center and AC is the diameter. That means this angle that is formed here, that is ABC, will be equal to 90 degree. Okay, this angle ABC is equals to 90 degree. And why is that so? Because it is the angle in the semicircle. Since angle in the semicircle. Now in this triangle ABC, okay, we have two angles here, so we'll be able to find the measurement of the third angle. So in triangle ABC, that is this triangle here, angle ACB, that is this angle here, plus angle ABC, ABC is this angle here, and angle CAB, that is this angle here, is equal to 180 degree. And why is that so? Because it is the sum of the angles of a triangle, so it will always be 180 degree. Okay, now we know the values of ABC and CAB, so we'll replace the value of ABC and CAB. So this is what we'll get, and adding this two will be getting 90 plus 40 is 130, and taking 130 on this side, we have angle ACB is 180 minus 130 degree. So we have angle ACB as 50 degrees. So the measurement of this is 50 degree. Now looking at the diagram, it's clear that this is the angle standing at the segment angle standing at AB, and this is also an angle standing at AB. We can say that this is the angle in the same segment. So angle X will be equals to angle ACB, that is this angle here. So they are the angles in the same segment of a circle are equal. So the measurement of angle ACB was 50, so the value of X is 50 degree. So this is how we solve this kind of problems. I hope that in this video you are able to understand how to solve this kind of problem. If you like this video, give it a thumbs up, and to stay updated with our channel, subscribe to the channel and turn on the notification bell. Thank you for watching and have a very good day.